recording, and then you can see my screen as well. Okay, so today is our 5th lecture, and what we are going to see is more the assembly tasks with a robot. So far, we have mostly discussed pick and place tasks, but if you try to look or try to understand the assembly process, assembly is also a pick and place process, but it is a sequence of multiple pick and place tasks. And many times there are 3, 4, 5, 8, 10 different components, and one robot or 2 robots or 3 robots are responsible for picking and placing of all these components in a sequence. But yeah, assembly becomes a little different from pick and place, that there is a sequence of tasks and also there is a precedence, that a defined sequence that in which the component should be placed. But primarily, assembly is also a combination of multiple pick and place tasks, but there can be some additional tasks as well. For example, screw driving or gluing or maybe sanding. So, but today we will see how assembly is done with a robot. As I said, that we will be working with Process Simulate. I have tried to make a very simple component, a product. So there is one base plate, and then there is a top plate, and then there are 2 screws. So the robot has to pick this first component, then pick and place this top component, and then mount 2 screws. So this is a very simple assembly that we would try to build with a robot. If you try to make an understanding of this, that if you are given this product, that okay, automate this thing with a robot, then how will you start the project, or what would be the first thing that you will do, or how you will decide the components or the resources that that are needed to build a cell or a robotic cell. So I have specified these this equipment that we need to build this assembly cell. This is all off-the-shelf equipment, meaning there are companies that are manufacturing this equipment. They are manufacturing it, they are selling it. So you can, if you need to buy a cell, you can just buy these equipment and then assemble together, and then your cell is ready. So we will use a robot, UR5E for today's task, then a gripper from Robotiq E-Pick. It is a vacuum gripper, so not a pick and place gripper with fingers. And then there is a screwdriver, a screw feeder, which presents the screws to the robot. Since we have 2 tools involved, one is a gripper and one is a screwdriver. So somehow either we should have 2 robots so that each robot is mounted with one of the tools, or we somehow should have a strategy to, or a technology or a technique, that how a robot can use both tools alternatively. So for that purpose, we will use this tool changer from Triple A company, and then we will use this Technicon table, robot table, which is from another company that is called Technicon. So the end result that we will build will look something like this, that we have a robot table, then there is a robot. This is the screw feeder, a fixture. A fixture I have placed that where the robot will place each component and perform the assembly task, because somehow it has to secure the components so that they are not moving during pick and place or during assembly activity. And then for each of the two components, you need some fixture or some method that how they are presented to the robot. So if you are using a fixture, then you don't need any camera, etc. So robot knows where each component is placed. So each location you have fixed it. This is why we call them fixture, that you have fixed the location. And by defining coordinate values, you can define into robot program for each component for their locations, and then the robot knows how to pick and place them. And then there are these tools. I hope you remember I had shown you a video in the first class that how this technique works. So there are three components. Maybe I can show you. So it is something this, and yeah, so there are two of this is tool side or gripper side component, and then a very similar component is attached to the robot, and the robot component fixes into it, and this is attached to the gripper, for example, or screwdriver, and then the robot can pick the component more easily. And if you want to change the gripper, then it will leave this one and pick the other one. So this is why we have, I will show you in a while in the simulation that how it is working. So this is the strategy for changing the tools, and this is the cell, how it will look like. Since it takes a lot of time to build the cell, so I have already built the cell. You don't need to create the cell for this exercise, but you will get the complete cell. I have uploaded it at Moodle. Maybe there is some problem, but you will get it in a while. So you will have the cell already developed in the simulation. The only thing that you need to do is to build the simulation and define the robot trajectory or robot path. So now we will try to do it or see how we can do it. So as I said that this is the cell. And this is the tool changing equipment or device. So basically this is a separate thing from screwdriver. There are no features of process simulate. The computer that I am using for now, it seems to be not a very good computer for graphics. Maybe I need to restart Process Simulate. when you will start working with simulation, I remember you told me that you have already done some work with Process Simulate for human ergonomic studies. But when you will be working with robot simulation, in the beginning, it will offer you several challenges. Also, when, for example, for your project, when you will build the complete cell, there will be several challenges in the beginning, but gradually you will learn how to do it, and so there is a learning curve involved for a beginner. Okay, as I said that we have this tool, and basically this is that thing which is attached to the screwdriver, and this is screwdriver. And then one of these are identical components, and then the other end of this set is attached to the robot. So this is attached to the robot as a gripper. There can be different techniques of using them, but for now I have attached it, or I have defined it as a gripper. So now you know how to define a gripper and how to attach it to the robot. But in this case, it does not have any kinematics because you can even delete them. They are just links not defined. So it has no pick and place because it is just a stationary component. There is no movement, or there are no dynamic components in it. But I have defined it as a gripper, and in that case, it will pick this one, then perform the pick and place, then place it back, and then pick this screwdriver, perform screw driving, and then place it back. Okay, so yeah, and one more thing, last time I had told you that when you are building the simulation, the components or the parts that a robot will interact with, it is better to create a flow operation for them, for each of that component. It will help you to bring that component to its default position. If you don't do it, when the robot will pick that component and move it, if you reset the operation, probably the object will not go to its original position or its default position. So how you do it, you just pick that component for which you want to save its original position, and then create a new object flow operation. Just click OK, and then the location that it creates, copy and place it again. Just Control C and Control V. So I have created these locations, for example, for the gripper, screwdriver, and now we have created this. It is a good idea that you create now you can see many different operations in this operation tree. It is a good idea if you create a compound operation for similar kind of operations. But as I mean that here you can create new compound operation. and I name it a reset. And I hold down the control key, and then I select all the reset operations and drag and drop into reset. So now if I will run this operation, it will always reset. For now, they are already placed at their original positions, but if they have been moved, if you will run just this reset, all the components will go back to their default positions. Okay, and then this is the robot operation that I have created, just a pick and place operation. It is not a complete operation. If I try to run it, it will, okay, you can see something weird things. Okay. So basically, if you select this, they are already attached to the gripper. I detach them. Similarly, this detach. Hmm. Okay. So yes, now we will start working on it. So when you create an operation, a pick and place operation for the robot, and just randomly define some a pick location, a place location, and it will appear to be in a very weird shape. The operation may be very strange shape where it will pick or drop the component, but you should not be worried about it. Just go to path editor. So in the sequence editor, first you create the operation, then go to path operation editor, and then select the operation that you have created. So now I have imported it into this path editor. I am basically deleting these motions. So basically I am just keeping this pick and place. And then if I go to if you right click it and select this mark pose, and if you go to pose editor, so that pose has, so this pose has also been saved. So now there is this home position, this pose 1, pose 3. So I will use this pose 1, and I will right click it and add current location. And with these markers, you can move any location, move up or move down. So this is my starting position for now. And then I select add location after. Maybe I take the other position just to start from the beginning. So at current location, this location becomes start. Then I tell the robot add location after. Actually, this object should not be appearing there. There is some graphical error that it is displaying another object here. I just ignore that one. So basically, this is the object that we have to interact with. So first, also in the real robot, when you are programming the robot, so first you align it with the component where you want to align or to pick the component. Then I move it back. So this will be my first location after start. Then I go to add location after. I move more closer to the gripper. Then add location after. And so here it will pick the components, pick the gripper. Then I tell it add location after. And in which direction should it go? Basically, so here is this component. To pick the component, it moved in this direction, but after picking the component, it should go upwards. But as you can see, it has not picked the gripper. Now we will tell it, I named it pick, but the software doesn't know that it is the pick task. So how I will do it, I will define this OLP commands. We will see it also later today as well in more detail. What you can do is that by default, the software already has defined this pick task. You can just copy and paste that commands from this OLP commands. So you so just click this one and select all these commands, Control C for copy. Click here and then V. Okay. Yes, now it has picked it. Move to location, I will not reset it. So this is the pick location, then we'll move upwards. Then I go to add location after. So basically, this is the component that I want to pick with this gripper now. Okay. Then add location after. And I will, sorry. So you may have to define several paths in between before you complete one task. And as I had said before, you need to align it with your location. And then you can move it upwards. So here it will pick the part. I rename it with, the location after. Okay, now it has not picked the part. How we will do it, we will again define a command to how to pick it. So, and how we will do it, we again will go to this OLP command section, click here. This window will appear and I will click this add standard commands, part handling, and for now I will use attach. And what I want to attach this object to the gripper. Okay. So now it has pegged it. You can use this different shading options to make things more visible. But if you are using lines visibility, then maybe it will become slower because it has more information to process. Okay, so here I want to this part. How to do it? OLP commands, add standard command, part handling, and now we will select detach. And here I need to detach this component. Okay, close. Okay, so now you have to basically we need to pick this component as well over here. Okay, I do it this one as well. The gripper should touch the component, otherwise it will, in most cases, it will not grab the component. Yes. So now I hope it will work fine. Okay. Okay, so now we have to place this tool back to its position from where it had picked it. Ideally, you should copy it the same locations. Also, when we are programming the real robot, we try to copy the same. Here you can find X, Y, Z positions. Either you can just note them down and copy and paste these for so that the robot follows the same locations that it had used for picking the components, picking the tool, and for placing the tool, basically it should follow the same XYZ locations. So how we can do it? Here we had picked the tool. So let's move to location. So I will use the same location at current location. And this will become my place location. And after placing, it should move backwards. This one. At current location, and I name it. It will go after place. But we also need to have a location before. So to place the tool, it should go from top to bottom. So in this case, it will come here, then it will go to place location, and then it will move back. Okay, so now I have created these two locations to place the tool, and I will take these to the end. And this we can delete. For place, we need to copy the commands. So I copy and place. Place. we had started it from here. You can name it start or home. Okay. Okay, so now I am running it in the sequence editor and let's see how it behaves. This is the wrong one motion is wrong. We can correct it. But other than that, it is working very fine. So this is how you define the path of for a task for any robot. If you remember the training that you had taken for universal robot, there was something about linear motions and joint to joint motions. If you see now we have almost, if I right click it and teach pendant, you can see that all our motions are point to point. By default, it creates all the motions as point to point. But can anyone tell me that what is the problem if you do point to point motions or what is the difference between linear motions and point to point motions? Anyone, whatever comes to your mind.
Linear motion moves from in a straight line, and the point to point will take whatever the shortest distance is.
Exactly. So in this case, it is taking all the motions at point to point, but the problem can happen that when it is placing the components in a fixture or picking or placing the tools from these holders, then a point to point motion can be problematic, and it can hit some other components. So ideally, all those motions where you want it to move in a straight line and not to be independent, that it chooses itself to find the shortest distance. So in that case, I would suggest that all the locations where you are picking some component and a couple of paths before and after it, they should be made as linear motions. So for each of them, you will need to go to teach pendant and then make it a linear motion. You can also define the speed, acceleration of for each motion. This is something more in detail when you are optimizing the path, and you can see that which are the safe motions, very safe, and you can make those motions more faster. You can make some, because for now it is running at constant motion speed, but you can make it that some of the motions are more faster and some motions are slower. So just to optimize the path. So for example, here I am making them linear motions. And you can also see that here it is showing the duration. So this is the total time that it will take, 30.84 seconds to complete this pick and place of the two components. And then you can play with it by reducing the speed or by increasing the speed, and then you can see how much effect does it make to the total time, total cycle time. Okay, but this is how we use this path editor to create a robot path planning. Once you have created a path, you can also use these layout planning tools. For example, for the robot, you can. Okay, for example, you have defined, until now we have defined that the robot need to go to reach this location, this, and then you maybe need to relocate the robot, and then you can ask the software that where can I place the robot. And in that case, okay, so now it is showing you that if you want to make the robot to reach these locations, these blue are the areas where you can place the robot. And these red ones are the ones where you should not be placing your robot, because then it will not be able to perform this operation. So this is how you can do some layout planning. There are many other tools as well, maybe some interesting ones are this is the volume of the robot. Actually, we haven't discussed robot volume yet more in detail, so we will do it. But robot volume is also something important, particularly when you are planning the safety things. Then you need to know how much volume robot is occupying. So basically, this is the volume that robot is occupying to perform this task. So you should safeguard your workers from this area, this much area. And, one very interesting feature of these simulation programs is that, for example, now you have created the simulation, you can visualize it. This is the very first and very basic benefit of creating a simulation, that you can see it, that how the process will look like. Then you can make the cycle time estimates and optimize the robot path, make safety analysis. Then you can use the same program to download to the robot. So all the effort that you might need to do to manually program the robot on TeachPendant, you can avoid it, and you can create a source file, and it will transfer this path that you have created, this program, to this script file that you can download to the robot. You can test it as well. If someone, this is not something that you have to do. This is just, I am telling that if someone of you is excited to experiment that how the program can be downloaded to the robot, you can download the TeachPendant of UR robot in your computer. It is downloadable from UR robot website. It is called, there is some name for it, but they have only one software at their website. So basically, you get the complete robot controller in your computer, and then you can generate the file and download the file to that robot controller, and it also will have, but still it will be a simulation kind of thing, but you will be able to see how it behaves in the actual robot controller, the same program. Hopefully we will have a robot, a UR robot as well within a month in our lab, and then you can test the robot program generated from the software. We can also connect. Okay, that is something I don't go into that detail, but we can live connect the robot with the real robot as well. And then in the real time, you are transferring your parts to the real robot. Okay, so until now we have seen this thing, that how we define robot path, how to pick one tool, perform a task, and place it back. Now you will pick the next tool. Similarly, the same way as I picked this tool, then pick this screw, place it on the assembly where you want to assemble it. And yeah, so basically this is something that I would like you to do it. Do you have any questions so far, or is there anything that you still don't understand and you want me to describe it? Because the reason that I am uploading these files at Moodle is that I want you to create these simulations. So you don't need to create any CAD thing, or you don't need to do any layout thing. Everything is already created, but you just need to define the path of the robot for each of these three components, 2 components and the screw. So this task or this assignment has at the moment higher precedence than your project. So even if we need to, because maybe some of you might need a bit more time, we can make a delay in the deadline of the simulation of the project. But this simulation, I would like you to submit today is Thursday, by Saturday. So Ideally, you should be doing it tomorrow at the latest, but okay, you can do it by Saturday. Do you find it challenging, or is there any problem? Or if someone, or if you think that this is not a good idea to do it?
My
Do you
only issue
have-
is, oh,
Go ahead, Taylor.
Oh, I was just, it's hard for me to find a computer with the simulation software on it. That's why I haven't been able to do the simulation or create a new one. I've been logging into the remote desktop for a few times, hoping that I'll get one, but
Okay, so you are not able to log into this remote desktop, right?
no, I can. It's just I can't find a computer once I'm on the remote desktop that has the program downloaded.
Okay, yes, because there is a limit of, I guess, 50 seats are available.
No, because I can get into the remote desktop. It's the downloaded programs that I'm able to use, or certain computers have certain ones, my knowledge. Like every computer I get does not have it downloaded onto it. Thus far.
Okay.
Yeah, so it's, I don't know if I have to go into the lab, but for me to do it remotely, I can't do it. That's my only,
Then it is a challenge. Yes, you should be able to do it remotely. Oh, well, then I need to ask it from IT. Then why, or is it the case, or what students should do in that case? Because you ideally you should be able to use the software remotely. But whenever I have connected, it always connects me to a computer that has Process Simulate. But maybe I am lucky that it is giving me Process Simulate every time.
In the past, I think even classes that had CAD in them, they would give us a remote desktop, like they give us a folder full of remote desktops that would work, and not icons, and we could click on them and it would take us to the mechanical engineering desktops.
Okay. Then basically my objective is that you should do the simulation by yourself, because there are several things, several concepts that that you can't learn only by watching it. So until and unless you don't grab the mouse and create the task, you will not be able to understand them. So okay, then we do it that you take it as an assignment, but there is no deadline for Saturday. Try to get access to Process Simulate. I will also send an email to IT and ask them that if this is the case, then what should students do? And if you don't have access, then it is not your problem. So, I mean, it is not due to your problem, your error. So then we will extend the deadline until you are back to the campus. Yeah. This is what I can think of for now. Yes, I can repeat it. So basically, the assignment is that you will get this complete layout. Everything would already be placed as you are seeing it now. The robot, all these equipment devices are placed like this, and you need to define the complete assembly sequence in the simulation. So you will first make the robot to pick this component, place here, then pick this component, place here. Okay, I repeat it again. First, pick this tool, then pick this component, place here, then pick this component, place here, then place this tool back. Then again pick this tool, which is a screwdriver, and then pick one screw from here, place the screw here, then pick another screw here, and place the other screw here, and then place this tool back to its position. So this is the assignment. There will be bonus points if you will create the screw. You really don't need to spend a lot of time on it, but you can make it to rotate the screw. I mean, you can show it that the screw is rotating when it is screw driving, and you can explore how to do it. One thing that I would like to mention, that when you will create 2 or 3 operations, I have already told you that how you create a compound operation. And if you will have a compound operation, you can drag and drop all your, for example, now I have created one compound operation of reset once. And then there is one compound operation of, for now I have only one robot task, but maybe you have multiple robot tasks. And now I've copied and pasted these 2 tasks. Maybe I create another copy. So now I have 3 robotic tasks of the same thing. So if I want to play them, I can just make this compound operation as set current operation. But now what is the problem? That all of them are will run at once. And if you assign a robot to run 3 operations at once, it will not run at all. I hope I am right. Yeah, so it will not run at all. So what you can do is that you can make one operation to start off once the other operation has ended. So either you just drag it and move it at the end. This is a manual way of doing it, and I will not recommend doing it. The reason is that when robot is working, maybe it takes less time, or maybe it takes more time to complete this. There can come a difference of a fraction of seconds. If it takes less time, then it is all okay. But if it will take more time, then it will get stopped here, and your robot will not move in this case. So they will stop. So ideally, how you should create this dependence is select first operation, then second operation, and then create this link. In this case, when the first operation has completed, no matter how much time it takes, then the next operation will start. Similarly, this operation and this operation. Yes, so now it will repeat the same motion again. Okay, so this is what you have to do. I hope you understand the assignment now. Feel free to write me if you still have any question. Oh, and you are welcome to ask if you have any questions for now, because this is all from my side for today. And I will be looking forward to receive your simulation models for this assignment for now. Isn't it interesting? I always found process simulate or robotic simulations or process simulation very exciting. Also, the fact that later you can connect it with a robot and can live transfer your robot program to your real robot or to a two-way communication. This sounds very exciting, I think. Yes, there was a question by one student about camera. Yes, we will also look into it, that how to integrate camera to the robot. Okay, yes, by using this feature connect to robot, you can connect it via Ethernet cable. So you need to connect Ethernet cable with this with your laptop, and the other with robot controller, and then robot IP address, and then basically it should work. Okay, yes, I will change the deadlines of the project that you are already working on. I think it is very little time to do all this in this given time. So I will extend the deadlines for the project. But for this, I repeat it that ideally you should be able to complete it by Saturday. But if by any reason you are not able to get access to the software, as some of you have said that you are having problems to get access to Process Simulate, in that case, I then basically a deadline doesn't apply, and then you can do it as soon as you can get access to the software, because I can't ask you to come to the university and work on it, because in these days I can't do it. So this is why there is no deadline. I will just upload. I will just make an assignment submission option, but without any deadline. So whenever you get able to get access to the software, complete this assignment. For the project, I will extend it at least by 1 week. So the deadline will not be Monday, but the next Monday. So yeah, I hope it is clear now.
My job is to make how to be testing. I don't know.
So they have not experimented with the real robot, rather they have used this virtual robot controller. So the complete teach pendant is installed in the computer. You can do it from your website, but I think there should be some video of a real robot. And as I said, you can also download the program and then import it into any robot teach pendant, and the robot will follow the same path or same commands that you have created in your robot program. Okay, so yes, this is all from my side. If you don't have any question for now, you are welcome to log off. But again, I will repeat that simulation, robot simulation, if by any chance you would like to explore it, or if you find it exciting, I really would encourage you to spend some time on it. It will take some hours of you, maybe some months of you, to become a good expert in it. But once you become an expert, or enough expert that you can create some simulations, it will really help you in, if you want to do something in automation, in manufacturing or something, this software will be of great help for you. So, and I know the software has a learning curve involved. In the beginning, it offers several challenges, but after spending some days, some weeks, you will get familiar with it, and then it becomes very exciting software, basically. Okay, this is all from my side for today. You will get the parts in Moodle in like 10 minutes for this simulation. Okay, thank you for joining. Have a nice evening.
I had just a question on my project. When you have a moment.
Yes. Do you want to ask the question?
Yeah, I'm seeing bringing it up. So
Okay.
our idea is